Welcome to the project demonstration of touchscreen control DC motor, setting up speed and also getting alerts if the speed is increased or decreased from the set speed. So here we are going to set the speed of this DC motor with help of 4-way resistive touch screens. So means we are going to set the DC motor speed in 4 RPS. So instead of RPM, for high accuracy we are going to measure this motor speed in RPS, that is revolutions per second. And based on this input from these two, the microcontroller will log the speed at this RPM, and to get this RPS, the microcontroller will be increase or decrease the speed of this DC motor with help of L298 motor driver, which was connected at C0, C1, C2 pins of our PIC16F72 microcontroller. And the speed will be measured by this IR sensor. So as we know that this work on the based on the reflection. So whenever this shaft rotates, the screw fitted to this shaft placed with the white tape, so it will be reflected, and the receiver will receive the signal and it will inform to the microcontroller. Whenever it's rotating, you'll get the pulses. The pulses will be counted per second. So that is, we are going to measuring the rotations per second, and that will be displayed on our LCD screen. And also, if the set speed is greater than or less than from this set speed, the main RPS, then the buzzer will be on and off based on the input signal from the microcontroller. Coming to this display, this is a 16:2 LCD display interfaced B2 to B7 of our microcontroller, and a buzzer at C4 and IR sensor at A4 pin, and these two touch screens are interfaced at A0 and A1 pins of our microcontroller. Coming to this motherboard, this red light is power LED indication and green light is parallelly on and off control from this buzzer, and this one is a reset switch, and also one more steel coated is there, steel plated, that is a crystal oscillator to provide the clock pulse to our microcontroller. So L298 is a HP circuitry. We can control the motor with speed controlling. And so let us see the demonstration. So when we switch on the gate, initially we set the speed for 8 RPS. Okay, and then so to reach that, the microcontroller will increase the speed. So the buzzer indicated, so the microcontroller controlling the DC motor to set means increase or decreasing the speed. So initially it will come with 0 speed, and slightly it will increase the speed. So for every second it's sending a pulse, means it's increasing the pulse width. So using PWM technique, we are going to control the speed of this. PWM nothing but pulse width modulation. We are going to increase the on time to increase the motor speed, and decrease the on time to decrease the motor speed in the PWM duty cycle. So here we can observe that. So whenever the shaft rotates, the particular light will be on and off. So then only we can get the high accuracy motor speed. So we get the more high motor speed with high accuracy. Second. Right. So we can see the speed is going to be the live speed of our DC motor set speed, which we have set already. So this speed was initially come with 8 RPS. So just wait till the speed set for the 8 RPS, and when it is set, so it will 8 RPS nothing but it will be plus or minus 1 RPS. So when it reaches 7, then the buzzer will be off and the speed also will be locked. So if it is increased or decreased also, the motor speed will be setting with help of duty cycle and the PWM signal from the microcontroller. So let us go with, I am setting for 4 RPS. Just hold on the 4 RPS till it has to display the 4 RPS. So we need to hold that position till we need to get the set RPS on our LCD screen, and now the motor speed is decreasing. So if I place higher one, just hold that at that position, and once it displayed the higher RPS, then you can remove that from the touch screen. And now we can wait, but it will take some time. Why? Because it has to increase the motor speed by PWM signal and check the speed. So this is a closed loop. Increase from this L298 motor driver and check the speed. So it's a closed loop. So while doing this closed loop, there may be some delay. So in order to maintain the high accuracy with same RPS which is set by the user, so it's maximum of 10 to 30 seconds based on the difference initial speed and the set speed. If it is nearby that period, for example 8 to 12, it will not take more than 10 seconds. From 4 to 14, it will take the more time. And coming to this buzzer, there is a transistor which will use it to on the buzzer, because the microcontroller can't drive the buzzer directly. So with the help of transistor, the microcontroller is going to on the buzzer. And here the flow is controller will on the transistor, the transistor will on the buzzer. So the main supply flow from this, we are going to provide the 12 volts from this adapter, and the 12 volts DC will be given to this L29 motor driver, and after that we will get the 12 volts given to this motor through this IC, as well as 5 volts to the motherboard as a power supply. So once you get the power supply, it start reading input from these two modules. So the two input modules are touch screen and IR sensor, and based on the signals we are going to control and display the data on the output module LCD screen, as well as buzzer indication along with LED indication. Thank you.